and this is a chord. It can be any chord. If I drop a perpendicular from the center to a chord, then that perpendicular will bisect the chord. So this is the center, this is a chord, and this is a perpendicular. That means this is a right angle. So this theorem says that this perpendicular will bisect the chord. That means it will divide this chord AB in two equal halves. Okay, so this length will be equal to this length. So if this point is P, then we can say that AP is congruent to PB. Okay, so a perpendicular drawn from the center to any chord bisects the chord. Okay, that was the last theorem which was left. So we have covered all the theorems, and there is one concept left for circles, which is based on number of revolutions. So Anishka, imagine that there is a wheel. Okay, there is a wheel, and this wheel is traveling. So this has spokes, and it's traveling, like it's rotating. Okay, and we have to find out, let's say, the distance it will cover in, let's say, 12 rotations. So how can you find out the distance covered in 12 rotations? Like it rotates in the clockwise direction. So what comes to your mind when I ask this question? Like, how much distance will it cover in 12 rotations?
Not sure.
Okay, let's see. First of all, like if this point is touching the ground, this wheel right now it's not moving, it's static, and this point is touching the ground. Okay, actually I should not say rotation, it should be, yeah, rotation. So now it rotates one time. Okay, it starts from here and it starts rotating, and it comes back to its original point, the point which was touching the ground. Okay, so what do you think would be the distance covered in just one rotation?
Like half
Half of?
half of the entire circle.
Mm, no, like it starts from here and it completes a full rotation. One full rotation. So like this point is touching, and then after one rotation again this point will be touching the ground. So that will make one entire rotation. So it starts, so like it starts like this. Okay, and it will complete one full rotation. So the distance covered in one rotation will be the circumference of this wheel. Don't you think? So that's the concept that we should know, that whenever a circular object is rotating, if a wheel is rotating, or let's say even a cylinder is rotating, so we should know that the distance covered in one rotation will be equal to the circumference of this wheel. So that is going to be 2 pi r, whatever is the radius of this wheel. Okay, that's the concept. So now if you want to find out the distance covered in 12 rotations, so all you need to do is just multiply So if in one rotation the distance is 2 pi r, the distance in 12 rotations will be 12 times the circumference. Okay, so the distance covered in n rotations will be 2n pi r. Okay.
Mm-hmm.
Okay, I'll give you one practice problem. Let's see if you can do it. Okay, so the problem says that there is a wheel that is covering 80 pi miles. Okay, and the radius of this wheel is 7 units. So we have to find out that in how many rotations it will cover this much distance. In how many rotations it will cover this much distance, 80 pi miles. I'll set a timer for 1 minute so that you are under pressure. Twenty seconds left. Okay, time is up. Were you able to solve it, Anishka?
Yeah, but I think it's wrong.
Oh, don't say that. We don't know. Okay. What answer did you get?
I got 560 pi.
565?
560 pi.
So 5.65. Is that what you're saying?
No, 560 pi.
Oh, pi. 560 pi.
Hmm.
Okay, so tell me your steps. How did you get 560 pi?
I just multiplied the two.
You multiplied 80 pi and 7. Okay, but why? So this, if you see the formula, it says that this is the distance 2 times n pi r, 2n pi r, that will be the distance for n number of rotations. For n number of rotations, distance covered in n rotations. Now in this question, the distance is given to us. This is the distance. Radius is also given to us, that is r. We have to find out the number of rotations. That means we have to find out the value of n. So if you multiply the distance and the radius, do you think that will give us the number of rotations?
No.
No. Okay. So see, what should you do instead? This distance, total distance in n rotations is given by n times the circumference, right? That's what we wrote, n times the circumference. This can be written as n times the circumference. And this distance is given to us as 80 pi. So I can write 80 times pi is equal to n times the circumference. Circumference is 2 pi r. I hope this step is clear,
Mm-hmm.
right? Okay, and the radius is also given. The radius is 7 units. So instead of this r, you just have to substitute 7, and then you have to find out the value of n. Can you try to solve for n?
Mm-hmm. 5.7.
5.7. Okay, fraction was the fraction 40 over 7?
It was 80 over 14.
Okay, it's correct. 80 over 14, if you simplify it, you'll get 40 over 7, and n is going to be 5.7. So that's correct. So this is the chances are very less that you would get a question from this topic, but it's always good to know all the concepts. Okay, you either know it or you don't know it. So if you get a question like this, you should know how to solve these type of questions as well. So Anishka, this completes the topic of circles. Let's just quickly see what all we did. We did the equations of circles. In the first class, we did a question type in which a circle is tangent to some axis. It can be tangent to the y-axis, it can be tangent to the x-axis. Then we did a question in which n points of a diameter can be given, and we have to find out the equation of the circle. Then we did a shortcut which allows us to find out the center and the radius by just using this formula, negative g comma negative f, and radius is square root of g square plus f square minus c. I'll be uploading these notes in the folders, so you can refer to these notes anytime. And this we did in the first class, and then in the next class we did arc length and sector area. We did two theorems on tangents. Then we did arc length and sector area. We did a formula for finding out the sum of angles in any polygon, and then measurement of one angle in a regular polygon. We did this. Then we did three theorems on inscribed angles, and we also did this concept where we have to find out that whether the point lies inside, outside, or on the circle. You remember all of these concepts, right? Or you want me to explain any concept again?
I think I remember them.
Yes, because now today we have completed circles. We will be starting the new topic of quadratics. This is all that we have to do in quadratics. First is how to solve quadratic equations. That's the first topic. Second topic is geometric interpretation of quadratics. The graph of a quadratic function is a parabola. So that will be our second big topic. We will first start with solving quadratic equations. Then in solving quadratic equations, we have to do three subtopics. First one is there are 5 methods to solve a quadratic equation. Method of factoring, completing the square, quadratic formula, graphing, and special cases. These are the 5 methods to solve a quadratic equation, and I'll tell you that in which type of question we have to use which method. Okay, how to identify that which method would be the best method to solve a certain type of problem. So that's first thing. I think we would be able to cover only first subtopic in today's class. We'll try to cover all the 5 methods in today's class, Anishka. Okay,
Mm-hmm.
so let's get started. Okay, here I've written zeros, roots, solutions, x-intercepts are used interchangeably. That means if a question says find out the zeros or find out the roots, find out the solutions, or find out the x-intercepts. It all means the same. It's just that these words are used for different notations. So if a quadratic is given in the form of equation, then we say find out the solutions of the equation. If it's written in the form of a function, then we say find out the zeros of this function. If it's given to you in the form of a graph, a parabola is given, then we say find out the x-intercepts of this parabola. And if it's well, roots are used in equation notation as well. I'll tell you the 3 notations for quadratics now. Okay, let's get started. Quadratics. Okay, first of all, the 3 notations. The first notation is ax squared plus bx plus c is equal to 0. This is called the equation notation. Equation notation. Second equation is when it's given like this: y is equal to ax squared plus bx plus c. This is called your relation notation, because a relationship is given between two variables, y and x. Then the third is called function notations, which will be like this: f of x is equal to ax squared plus bx plus c. So this is called the function notation. Okay. When we solve an equation, we find out the values of x. So we say that these are the roots or the solutions of this equation. And when we find out the, like if we put it equal to 0 and we find out the values of x, we say, like in the third case, we say that these are the zeros of this function. Okay. Okay, these are the notations. Now there are 3 forms of a quadratic equation, Anishka. Okay, so first one is this: ax squared plus bx plus c is equal to 0. This is called the standard form. Now for equation, we are seeing the 3 different forms. So this is called the standard form. Then we have the vertex form, which is given by x minus h whole square plus k is equal to 0. This is called the vertex form. Then we have the factored form, which is given by x minus p times x minus q is equal to 0. This is called the factored form. Now today what we are going to see is that how we can convert a standard form to the vertex form, standard form to the vertex form, or standard form to the factored form, or vice versa. Take any permutation and combination, we should know like how to convert the one form into any other form. Okay. Okay, so there are 5 methods for this. First is the method of factoring. Let's say we have this quadratic equation, Anishka: x squared minus 5x plus 6 is equal to 0. First of all, do you know the method of factoring?
Yeah.
Yeah. Okay, so can you tell me the solutions of this equation by using the method of factoring?
Is it 3 and 2?
3 and 2, perfect. So x is equal to 2 and 3 are the two solutions of this quadratic equation. Now, how the question will be asked. So you won't be asked to solve a quadratic equation. That's a very basic question. The question will be asked in this form that they will give you, instead of giving an equation, they can also give you an expression. So this is just an expression. Unless we put it equal to something, it's an expression unless we put it equal to something. So the question can be asked in this way, that factorize this quadratic expression into product of two linear factors. So it will be factorize the given quadratic expression into the product of two linear factors. So your answer will be x minus 2 and x minus 3. So this can be written as x minus 2 times x minus 3. That will be the answer. Okay. So this is the question in which you should use the method of factoring. Okay. Other way the question can be created is this. They will give you the factored form, but they will not give you 2 and 3. So they will say that if this expression can be written as x minus p times x minus q, then find out the value of p plus q. Find out the value of p plus q. So if this expression can be written like this, so what will be your answer?
Five?
5. Yes, exactly. So once we know how to write this in this form, so it's gonna be x minus 2 times x minus 3. So that means p is 2, q is 3. So the answer p plus q is going to be 5. Okay. So from the method of factoring, these are the two question types that you can expect. Okay. There is one more question type. I'll tell you that question type when we do geometric interpretation, because it involves the graph, the features of parabola. Okay, let's move on to the next method, Anishka, that is the method of completing the square. Do you know about the completing the square method?
Yep.
Perfect. So can you take the same quadratic equation, this one, x square minus 5x plus 6 is equal to 0, and can you write it in the vertex form, which is x minus h whole square plus k is equal to 0. Let me know once you finish it.
Yeah, I'm done.
Okay, so can you tell me the vertex form?
The x minus 5 whole squared minus 0.25.
Is it x minus 5 or is it x minus 5 1/2?
Oh yeah, 5 1/2.
So x minus 5 over 2 whole square minus 1/4 equal to 0. Okay, so good that you know this method already. Now, how the questions can be asked from this method? They can ask you to find out the vertex of the parabola. So they will give you, instead of giving, okay, one more thing, you should also know how to get the solution using completing the square method. So like the two solutions that we got, 2 and 3, we should get the same solutions by this method as well. So if we try to solve it, then it's gonna be, if you try to isolate x, 1 over 4 will go on this side, and one solution will be, so you take its square root, then you do plus 5 over 2. I'm just doing the steps quickly, and 1 over 4 square root um, minus 5 over 2. Okay, so again you should get 2 and 3 as your solutions, but they will never ask you to, you know, solve a quadratic equation by using the method of completing the square, and it's not advisable to use this method to solve an equation. When will you use this method? When the question is like this. So if they say that find out the vertex of the parabola for this function, so they'll give you the equation in the function notation that f of x is equal to x square minus 5x plus 6, and you must be knowing already that the graph of a quadratic function is a parabola. Okay, and in the vertex form, the vertex is given by, the coordinates of the vertex are given by h comma k, right? So once you convert the standard form to the vertex form, your vertex is h comma k. So can you tell me the vertex for this equation, for this function? For this one,
2.5.
that's just the x coordinate. You have to find h and k both. You compare it, compare these two
Oh,
equations.
1/4.
5 over 2 and,
1/4.
are you sure 1/4?
Negative.
Negative 1/4. So you compare. So k is equal to negative 1/4 and h is equal to just 5 over 2. So that's another way of asking the question, that find out, actually that's the first way the question can be asked, find out the vertex of parabola, and the function will be given to you. The second way the question can be asked will be that they will just remove the constant term, and instead of this they will write a variable. So for example, they'll say that if this quadratic equation can be written as x minus 5 over 2 whole square plus, let's say, c. So this one, x square minus 5x plus c is equal to 0, can be written as this. Then what is the value of c? So what will be the value of c?
6 minus 1/4.
No, you just have to compare the one that you got, x minus 5 over 2 whole square minus this, compare it with this equation. So you got x minus 5 halves minus 1/4 is equal to 0. So you just have to compare these two equations and Tell the value of C. Hello?
Yeah.
What happened? So what will be the value of
Fourth.
C?
C would be minus 1/4.
Yes, C would be negative 1/4. So this is the second way the question can be formulated. Okay, they will just remove this 5 over 2. Instead of this, they'll put another variable. So you should know how to convert the standard form to the vertex form. Then it doesn't matter what they ask. You can just convert it in the vertex form and you can tell any value. Okay. The third way the question can be asked is, so we have done two ways. The third way the question can be asked is, what will be the minimum value of this function? I'm writing it here. That's the third way. What will be the minimum value of the function? They'll give you this function. F of x is equal to x square minus 5x plus 6. So any idea how we can find out the minimum value of a quadratic function?
Do we find the vertex?
Yes, we'll have to find out the vertex. I've already plotted the graph. This is the graph for the given equation, x minus 5 over 2 whole square minus 1/4. And you can see that the vertex is 5 over 2 and negative 1/4. Right? So that's the vertex. Also, you can find out the vertex by plotting the equation on Desmos. So you don't you can skip doing the completing the square method. You can just straight away come to Desmos and you can plot its graph and you'll get the vertex. Okay. Now the minimum value, we were talking about the minimum value. In this case, the minimum value you will get, the minimum value will be the y coordinate of the vertex. Minimum value will be the y coordinate of the vertex, which is negative 1/4. So in this function, Anishka, if you have this function f of x equals x square minus 5x plus 6, no matter what x you take, the minimum value that you will ever get is negative 1/4, because this graph is not going below this line of negative 1/4. And you will get this minimum value when x is equal to 2.5. So this question can be also asked, that at what point we will get the minimum value of this function. So we'll get the minimum value when x is equal to 2.5, and that value is going to be negative 1 over 4th. Okay, is this clear?
Yeah.
Okay, there is another way of finding out this minimum value. Now there is another way which says, which in that method you don't even have to convert the standard form to the vertex form. You can straight away tell the answer, like you can find out the x coordinate by this formula, negative b over 2a. So if you have the equation given in the standard form, so if you have x square minus 5x plus 6 is equal to 0. First, can you tell me what is a, b and c? So if this is ax square,
A,
hmm,
A is 1, B A is -5 and C is 6.
So A is 1, B is -5, and C is 6. Okay, so this expression negative b over 2a, this will straight away give us the x coordinate of the vertex. So if you do negative b, that means negative of -5, so that's +5 over 2a, 2 times 1, that is 2, so you're getting 5 over 2. That's the x coordinate of the vertex. Okay, and if you have to find out the y coordinate, then you just put this value in the function. Okay, if this was f of x is equal to x square minus 5x plus 6, then you just find out what will be f of 5 over 2. So you do 5 over 2 whole square minus 5 times 5 over 2 plus 6. This is gonna give you the y coordinate of the vertex. When you solve this, you will get -1 over 4. Okay, so this is the y coordinate of the vertex, and this is also the minimum value. Okay, so you can find out the minimum value and the vertex by these two methods. But you can either plot the graph on Desmos, or you can complete the square, or you can use this shortcut -b over 2a. Okay,
Okay.
just let me know if it if it becomes too much information to to absorb in one day, because it used to happen with me when I used to do a lot of new topics in one day. Then my brain was never able to recollect anything at the end of the class.
Yeah, I got it.
Okay, so this was the method of completing the square, and this is how you can expect the questions. The third method, Anishka, it is quadratic formula. Do you know the quadratic formula?
Yeah, it's negative. Yeah, it's b squared minus 4ac over 2a, right?
Sorry, I lost you for last few seconds. Can you repeat that?
It's b squared minus 4ac over 2a, right?
No, I think you missed negative b. So it's negative b plus and minus square root of b square minus 4ac over 2a. So if we have a quadratic equation, ax square, and quadratic formula can be only used when the equation is given in standard form. Okay, so if we have this equation, then the solution can be given by this expression: negative b plus and minus square root of b square minus 4 times a times c whole divided by 2a. This is the quadratic formula. Okay, so we can, if we want, we can solve the same equation that we did, x square minus 5x plus 6 is equal to 0, and a will be 1, b will be -5, c will be 6. If we put those values in this expression, we will get 2 and 3 as the solutions. Okay, so again, you will not be like, you will not need this formula to solve the equation, but you will need this formula to find out the nature of roots. The nature of roots. We will do the nature of roots right now. So what do you understand by nature of roots, Anishka? Nature of roots of a quadratic equation. Nature of roots. Hello?
Oh, I was muted. I said to find the roots of an equation.
Okay, but do you know the meaning of nature of roots?
No.
Okay, so see, we know this that every quadratic equation has two roots, right?
Mm-hmm.
Now those two roots can have three type of nature. First is that those two roots can be real and distinct. So both of them can be real and distinct. Uh, for the equation that we just did, this one, x square minus 5x plus 6 is equal to 0, we got the roots as 2 and 3. So both 2 and 3 are real numbers and they are distinct. That means 2 is not equal to 3. Both of them are distinct, right? So this was the case of two real and distinct roots. So that's the first case. Second is you can have one real root, okay? Or at some places they also say uh, two repeated roots, okay? Two repeated roots. This will be the case when it will seem like you're getting just one solution. For example, if you have a quadratic equation like this, x minus 4 whole square is equal to 0, okay? If you try to solve this equation, you will get x is equal to 4 and 4, because the two linear factors will be x minus 4 times x minus 4. We'll do this in special cases. This is a special type of quadratic equation, and in this case you will get only one real root, that is 4, or we say that two repeated roots. That's the second case. And the third case is, can you guess?
Zero roots.
Zero real roots. Yes, zero real roots, or we say imaginary roots, or we say the roots will be complex numbers, okay? Now how can we tell that whether the roots will be real and distinct, or they will be repeated, or they will be imaginary, without solving the equation? Without solving the equation, for that we just have to calculate this quantity under the square root, b square minus 4ac, okay? So the quadratic formula is majorly used to tell the nature of roots, okay? We don't use it much to solve the equation, we only use it to tell the nature of roots, and this quantity is called the discriminant. It's denoted by capital letter D, okay? So if this D is greater than 0, then you will get two real and distinct solutions. If this D is equal to 0, b square minus 4ac comes equal to 0, then you will get one real root or two repeated roots. And if this D is less than 0, then you will get no real roots or imaginary roots, okay? But you'll be never asked to find out those imaginary roots, because imaginary numbers and complex numbers is not in the SAT math curriculum. It was there till paper SAT, but with digital SAT they have removed complex numbers. So you'll never be asked to find out those imaginary roots, but you can be asked to tell the nature of the roots, okay?
Okay.
Okay, so if you find out, can you quickly calculate the value of D for this equation, Anishka, for x square minus 5x plus 6 equal to 0? x square minus 5x plus 6 is equal to 0. So find out the discriminant.
Is it 1?
Yes, it's going to be 1. So 1 is greater than 0, right? So that means, so for x square minus 5x plus 6 is equal to 0, the discriminant, we got 1, which is greater than 0. So that means this equation is going to have two real and distinct roots. Okay? Okay, so this
Mm-hmm.
is the first way in which the question can be asked, that they'll give you an equation and they'll ask you that what will be the nature of the roots. So like they'll give you four options, that the equation will have two real and distinct roots, or two repeated roots, no solution, no real solution. They'll give you four options, or none of the above. So all you have to do is just find out the discriminant, check whether it's greater than 0, less than 0, or equal to 0, and you'll get your answer. The other way the question can be formed is that they will remove some constant. So instead of this equation, they'll tell you that x square minus 5x plus c is equal to 0, and they will ask for what value of c, this quadratic equation will have no real roots. So can you tell me the values of c, Anishka, for which you'll get no real roots, and you'll get an interval, you'll get an inequality.
Is it minus 21?
Minus 21. Okay, so that means just minus 21.
Yeah.
Okay, can you tell me how did you get minus 21?
I did negative 5 squared minus 4 times 1 and then times c equals 0.
Hmm.
And then I
Okay,
solve for c.
so what is negative 5 whole square?
25.
Okay, this you put it equal to what?
0.
Would it be equal to 0? Just check the condition for no real roots. What's the condition for no real roots?
Oh, it'll be less than 0.
Yes, we'll say less than 0. So that's why I said your answer will be an inequality. Okay, so then negative 5 whole square is 25, minus 4 times c is less than 0. Can you tell me what will be c now?
Yeah. It'll be greater than 25 over 4.
Yes, so c will be greater than 25 over 4. So you'll get four options like this. Like c is greater than 25 over 4, c is less than 25 over 4, or c is greater than negative 25 over 4. The options will be really confusing, or none of the above. Okay, so first solve your, like, you don't look at the options, try to solve your question. When you get your answer, then look at the options. Okay, so this is how you can get questions from, what is this, quadratic formula. Okay, I think we have done 3 methods: factoring, completing the square, and the quadratic formula.